Today we're going to solve more systems of equations. Last time we did it by graphing. Today we're going to do it by addition. And I kind of wish it actually said by addition or subtraction. And I'll show you why in just a second. So remember last time we solved these systems of equations by graphing, and there was a couple of problems that we found with it. One is it takes a long time. Second one is that the solution might not fit on the graph. And the third thing was that the solution might not be a pretty point, and then it's very hard to get an accurate answer. Those problems are all alleviated by this method we're going to do today. You'll always get the exact answer, and you won't have to worry about it fitting on a graph or anything like that. Alright, before I actually show you the steps for doing this, I want to show you something. If I have these two statements, 7 plus 3 is 10 and 5 plus 2 is 7, I think you'd probably agree with me with both of those. I want to show you a couple of things. One, if I add all these columns together, 7 plus 5 is 12, 3 plus 2 is 5, plus 5 because positives, and 10 plus 7 is 17. Is this still true? Yeah, 12 plus 5 is 17. Okay, how about if I was to subtract? 7 take away 5 is 2, 3 take away 2 is 1, and 10 take away 7 is 3. True? 2 plus 1 is 3? Yep, that's true too. Okay, what about if I do this? I'm going to multiply this first one, all the terms by 2, and let's see what we get. 2 times 7 is 14, 2 times 3 is 6, and 2 times 10 is 20. Is that true? 14 plus 6 is 20? It sure is. Let's do one more. Let's multiply this one by, I don't know, let's multiply it by 4. So multiply all this equation by 4. If I do that, 4 times 5 is 20, 4 times 2 is 8, and 4 times 7 is 28. Okay, that's true too. 20 plus 8 is 28. And last thing, now let's add all these columns together. 14 plus 20 is 34, 6 plus 8 is 14, and 20 plus 28 is 48. And yes, this is true as well. 34 plus 14 equals 48. Why am I showing this? Because these are the sort of steps you're going to use in order to solve questions, systems of equations by subtraction and addition. And I just wanted to show you that it actually works when you add equations together or subtract equations. You don't break any rules when you do that. Okay, so here's the steps. It's a lot to write. I'll kind of write them quickly. Write both equations in standard form. Standard form, you know, is ax plus by equals c. Second thing you're going to do is you're going to multiply the terms of one equation, or both equations, by a number to make the coefficients of one of the variables exactly the same, or opposites. That is so confusing, but once you see it, you'll get it. Number 3, add the equations if the variables are opposites, or subtract the equations if the variables are the same, and solve the resulting equation. Step 4 is to substitute your value from step 3 into one of the original equations, and step 5 is to check your solution in both the original equations. Okay, probably doesn't make a heck of a lot of sense to you right now. Why don't you pause the video, write all that down, and then we'll go over it. Okay, so the first question here, we have two equations, and step 1 says to write them in standard form. ax plus by equals c. ax plus by equals c. Yes, they're both in standard form. Okay, now what we want to do is we have x's in both of them and we have y's in both of them. We want to get the coefficients in front of the x and the x's either exactly the same or opposites. What do I mean by opposites? I mean like 2 and negative 2, 4 and negative 4, 6 and negative 6. Or if we can't do it with the x's, we want to do it with the y's. We want to get the numbers in front of the y's, the coefficients in front of the y's, exactly the same or opposite from each other. Now, what do you notice? You've already done this, or you haven't done it. It's already okay in this question, because which coefficients are exactly the same? The coefficients in front of the x. There's a 1 right here, there's a 1 right here. So this is great. You don't actually have to multiply anything to get them the same. So you're going to be able to go straight to step number 3. So before we do that though, let me just number these equations. I'm going to call this equation 1 and I'm going to call this one equation 2. Okay, and what I'm going to do is, usually I'd be multiplying them or something like that, but I'm just going to rewrite them. So I have x plus 2y equals 5, and I have x minus y equals 2. And we said we're already happy with this because we have the same coefficient in front of this x. We have a 1 right here, and we also have the same coefficient here, a 1 there. So I'm going to take those away because we don't usually write the 1s, but we do have a 1 here and a 1 there. So what we do now is we add the equations if the variables are opposites. Well, these aren't opposites, they're both 1. Or we subtract the equations if the variables are the same. Here we have the variables the same. It's a 1 and a 1. So what we're going to do is we're going to subtract the second equation from the first equation. Why are we going to do that? Well, let's see what happens when we subtract. We get 1x, take away 1x, which is no x's. You don't have to write that at all. Then we have 2y, take away negative, remember this is like a 1 here, so it's 2y, take away negative 1y. 2 take away negative 1 equals 3. So we have 3y equals 5 take away 2 is 3. Now, why are we happy with this equation? Way more happy with this one than what we started with here. Because instead of having 2 unknowns, we now are down to 1 unknown, and we can totally solve this. 3y equals 3. This means 3 times y equals 3. So what do we have to do to both sides? We have to divide. Divide by 3, divide by 3. These 3's cancel out. We're left with y equals 1. Awesome, we just figured out what y is. Now we have to go to step 4. We have to substitute that value, that 1, into one of the original questions, one of these original equations. So, I don't know, let's substitute into, which one looks easier? It'll work in both of them. I'm going to substitute into 2. So what that means is I have x take away, I'm not going to write y, I'm going to write 1, because that's how much y is, equals 2. And now all I have to do is solve that. Well, that's no problem. Plus 1, so we end up with x equals 3. There's my answer. My answer is that x equals 3 and y equals 1. Or the other way you can write it is you can put as an ordered pair, 3, 1. Just make sure you always put the x first. So this is your answer right here. Or over here if you want, but I'm going to write it like that. Alright, we're done. There is one last step here. It says to check your solution in both the original equations. You don't have to, but it's not a bad idea. So I will do that. I'm going to check. In equation 1, we have x, which is 3, plus 2y, which is 1, and we're saying that equals 5. Is that true? 3 plus 2 times 1 is 2. 3 plus 2 is 5. Yeah, that's true. In number 2, equation 2, we have x, which is 3, take away y, which is 1, and it says it equals 2. Is that true? Yeah, that's true. This is definitely the right answer. We're finished. Okay? They're all just like that. So, here we go. Second question. I'll just number these 1 and 2. First thing we want to do is we want to write them in standard form. So number 1's already in standard form. 4x plus 2y equals 16. Second one's not in standard form. We have 5x, but I want to move the 2y over so it becomes minus 2y. And I have to move the negative 29 over so it becomes positive 29. Okay, now we have to look to see which coefficients can we get the same or opposite. So which letter do you see is going to be easier to deal with? It's going to be y in this case. And look at, in front of this y there's a 2, and in front of this y there's a negative 2. They're opposites. Again, we don't have to multiply them by anything. We're already ready to go. What are we going to do in this case if they're opposites from each other? If they're opposites, we're going to add. So we are going to add these equations. Going to add the whole thing. What do we get when we add that? Well, we get 4x plus 5x, which is 9x. We get 2y plus negative 2y. That cancels out completely. It's 0. So we don't have to write that. And we get 16 plus 29 is 45. Again, we're left with a very simple equation to solve. Divide by 9, those cancel. We're left with x equals 5. Awesome. Let's substitute back into one of the original. Doesn't make a difference which one you sub into. I'll sub into the first one, I guess. So if I sub in there, I get 4 times x, but x is 5, so 4 times 5, plus 2y equals 16, and I have to solve that. So 4 times 5 is 20, plus 2y equals 16. You got to take 20 away from both sides. So you get 2y equals negative 4. Then you got to divide by 2 and divide by 2. So you're left with y equals negative 2. Our answer is x equals 5 and y equals negative 2. Or you could just write it as 5, negative 2. Let's check it again. So in the first equation, we have 4 times x, so that's 4 times 5, plus 2 times y, so that's 2 times negative 2, and it has to equal 16. Is that true? Well, 4 times 5 is 20. 2 times negative 2 is negative 4. 20 plus negative 4 is 16. Yeah, that's true. Second one, 5 times x, which is 5, take away 29 equals 2 times y, which is negative 2. 5 times 5 is 25, take away 29 is negative 4. And on this side we have 2 times negative 2, which is negative 4. It worked. It's all good. Okay, this one's a little bit more difficult. I'll number the equations 1 and 2. So, they're in standard form, so I'll just rewrite them here. 3x minus 4y equals negative 18, and 6x minus 5y equals negative 27. Now, 3 and 6, those aren't the same and they're not opposite. Negative 4 and negative 5, those aren't the same and they're not opposite. So what can we do, though, to get them the same or opposite? Do you see which variable, which letter, x or y, is going to be easiest to get the same? It's going to be the easiest to get the x's the same. And how are you going to do that? You're going to multiply this first equation up here. You're going to multiply this whole equation by 2. Maybe I should write this over here. Multiply equation 1 by 2. So that's what we're going to do. We're going to multiply by 2. We're multiplying 2 times this, 2 times this, and 2 times this. It's not really the distributive property or mountains. We're multiplying the whole thing. Okay, I showed you that on that right at the start when I showed you this, how you could multiply all of these things, and it works out to something that's still equal. Okay, so let's go down and do that. If we multiply everything in the first one, you end up with 2 times 3x is 6x, 2 times negative 4y is negative 8y, and 2 times negative 18 is negative 36. There's no need to multiply anything on the bottom, because look at, once I write that 6x, I now have the same thing right here. Perfect. 6x minus 5y equals negative 27. So 6x and 6x, do I want to add or do I want to subtract? Well, I want them to disappear, so don't add, you'd end up with 12x. I want to subtract, so they'll disappear. 6x, take away 6x is 0, don't need to write it. Negative 8y, take away negative 5y. That's the same as negative 8 plus 5y, that's negative 3y. Negative 36, take away negative 27. That's the same as negative 36 plus 27, that's negative 9. Be careful here, how are you going to solve this? This is negative 3 times y, so we have to do the opposite. We need to divide by negative 3, and divide by negative 3. So these cancel, and what you're left with is y equals 3. Great. Now we need to figure out what x is. Why don't we sub this 3 into, I don't know, it doesn't matter which one, the first one I guess. So if we do that, you end up with 3x, take away 4 times y, which is 3, equals negative 18. 3x take away 12 equals negative 18. Now we need to add 12 to both sides. So 3x equals negative 6, and then divide by 3, we get x equals negative 2. So our answer is x equals negative 2, y equals 3, or you could write it as negative 2 comma 3. That's our solution. Should we check that? Why not? So check 1. The first one would be 3 times x, which is negative 2, minus 4 times 3 equals negative 18. Is that true? 3 times 2 is negative 6, 4 times 3 is 12, and we're subtracting, so negative 6 take away 12 is negative 18. Yep. Second one, 6 times x, negative 2, take away 5 times y, which is 3, equals negative 27. 6 times negative 2 is negative 12, 5 times 3 is 15, and we're subtracting, so negative 12 take away another 15 is negative 27. Correct. Okay, next one. Let's number these, 1 and 2. Whoa, it's a terrible one. And let's write them in standard form. So the first one, 3x plus 2y equals, we got to get this 6 to the other side, so negative 6. And the second one, whoa, let's bring the 5x over, so we get negative 5x. It's okay, I know in standard form we like that first one to be negative. When you're doing these questions, you actually don't have to worry about the first coefficient being negative. So negative 5x plus 7y equals 41. By the way, if you had moved the 7y over and the 41 over, it's fine. I know your signs would be different, but it would still work out. That's the cool thing about this. So let's look at which of them are going to be easiest to get the same. Is it going to be easier to get the x's the same or the y's the same? Well, actually, it's not going to be very easy to get either of them the same. There's nothing you can really multiply 3 by to get 5. I mean, there is 5 over 3, but we don't want to do that. There's nothing you can multiply 2 by to get 7. Well, again, there is 7 over 2 or 3.5, but that doesn't work. We don't really want to do that. But what could we multiply them? We could multiply this by one thing and this by something else. Why don't we get the x's the same? It's kind of like asking yourself, what's the lowest common multiple of 3 and 5? Lowest common denominator if you want. Lowest common multiple is 15. How do we get 15? Multiply the top one by 5, multiply the bottom one by 3. This will work. If you wanted to get the y's the same, you'd multiply the top one by 7 and the bottom one by 2 to get a common denominator or a common multiple of 14. So you have to multiply them both in this case. Okay, what do we end up with when we do that? 5 times 3x is 15x. 5 times 2y is 10y. And 5 times negative 6 is negative 30. Down here, 3 times negative 5x is negative 15x. 3 times 7y is 21y. And 3 times 41, my goodness, it's 123. Now, 15x, negative 15x. Do we want to add or do we want to subtract? You want to add. If you subtract, it'd be 15x take away negative 15x, which is the same as 15x plus 15x. You'd have 30x. Don't do it. You want to add these. So 15x plus negative 15x is 0. That's gone. 10y plus 21y is 31y. And negative 30 plus 123 is 93. Looks scary, but it's actually going to work out fine. When you divide by 31 and divide by 31, y equals 3. Perfect. Now we need to substitute. Does it matter which one you substitute in? No, it doesn't. Let's sub into the second one. I don't know why. That's what I'm going to do. So 7 times y, which is 3, equals 5x plus 41. 7 times 3 is 21 equals 5x plus 41. Got to get the 5x by itself, so let's subtract 41, subtract 41. So negative 20 equals 5x. Then divide by 5, divide by 5. You get x equals, negative 20 divided by 5 is negative 4. Your answer is negative 4 and y equals 3. Or you could just write it as negative 4, 3. I'll leave you to check that one yourself, but I do promise you that it does work. Okay, this dreaded one. Now, I think this is actually above and beyond what you need to know, but there is some of these in your workbook. So you have fractions. Yikes. So if I number these 1 and 2, I have 2x over 3 plus y over 2 equals 6, and x over 6 take away y over 4 equals 0. And I got to get them the same. Well, think of this y over 2 is the same as 1y over 2, or 1/2 y, and this y over 4 is the same as 1y over 4, or 1/4. I think it's going to be easiest to get the y's the same. What can you multiply 1/4 by to get a half? Think of it this way. How many quarters do you need to get a half? You need 2 quarters. So if you multiplied all of this by 2, it will work out. Now, I know that's difficult, especially for those of us who aren't so great with fractions. I don't want you to get too worked up over these fraction ones. I doubt that it will be any of these on the provincial exam. I'd be very, very surprised. And on the test that I give you, at the most, I'll give you 1 of these, so it's not going to cost you much. But it's a good kind of enrichment question, so I will put it on. Okay, so we do nothing to the first one, just leave it the same. 2x over 3 plus y over 2, or 1y over 2 if you want, equals 6. And on the bottom one, 2 times x, remember this is 2 over 1. It's not 2 over 2, it's 2 over 1. So you get 2x over 6. Or you could cancel that. I'll write it up here, 2x over 6. But the 2 and the 6 you can cancel and make it 1x over 3. I hope that makes sense. So you have 1x over 3, take away. Again, 2 times 1y is 2y, and 1 times 4 is 4, but you can cancel the 2 and the 4, and it gives you 1y over 2. So just to kind of save some space, I'll write it like that. And 2 times 0 is still 0. You do that as well. Look at 1y over 2, 1y over 2. They're opposites from each other. So are we going to add or are we going to subtract? We're going to add all of this. So 2x over 3 plus 1x over 3 equals 3x over 3. 1y over 2 plus negative 1y over 2, that cancels out completely, and this equals 6. Hey, 3 over 3, we can cancel those. All we're left with is x equals 6. We figured out what x is. Nice. Now it's time to substitute. Let's substitute into the second one. So if we substitute in the second one, we get x over 6, which is 6 over 6, minus y over 4 equals 0. That's a y over 4. 6 over 6, that's the same as 1. So we get 1 minus y over 4 equals 0. Let's move the y over 4 to the other side. 1 equals y over 4. And since this is divided by 4, we're going to multiply by 4 and multiply by 4. Those 4's cancel. You're left with y equals 4. Our answer is x equals 6, y equals 4, or 6, 4. Scary, scary fractions. If you want to try it out, to check it, I'll just cheat here and just write a 6 here and a 6 here and a 4 here and a 4 here, and we'll see if it works. 2 times 6 is 12, divided by 3 is 4, and 4 over 2 is 2, and 4 plus 2 is 6, and that's exactly what it should equal. 6 over 6 is 1, take away 4 over 4 is also 1, and that equals 0, and that's what it should equal. Yep, it works. So it's all good. Okay, two last ones here, important kind of exception ones. So let's rewrite this in standard form. We have 5x, oh here's 1, here's 2, 5x minus 2y equals 1, and the bottom one, take that sign with that, so it's negative 10x plus 4y equals 11. Let's get the x's the same, or in fact let's get them opposite. So what do we have to do? We have to multiply the top one by 2. And if we multiply that by 2, you get 2 times 5x is 10x, 2 times negative 2y is negative 4y, and 2 times 1 is 2. On the bottom we have negative 10x plus 4y equals 11. Okay, what are we going to do? We're going to add or subtract. Look at, we have the x's exactly the same. Oh, they're opposites actually, so we're going to add them. So when we add 10x plus negative 10x is 0. Negative 4y plus positive 4y is also 0. So on this whole side, there's nothing left there. On the left-hand side, there's 0. Equals 2 plus 11 is 13. 0 equals 13. What the heck is this? Is this true? 0 equals 13? No, this is not true. This is never true. This is just some strange erroneous statement. And if you get something like that, that 0 equals 13 or 0 equals 11 or 2 equals 9 or something like that, that means that there is no solution. In other words, if you were to graph these two lines, what do you know? They'd be parallel lines. Okay, last one, pretty kind of similar to this. 1 and 2, let's put them in standard form. 4x minus 10y equals 22. And negative 2x, again, I know that's not standard form because of the negative, but it's okay with these, plus 5y equals, move the 11 over, you get negative 11. Let's get the x's the same again, or opposites again. We'll multiply the bottom one by 2. And if you multiply that, the top one stays the same, 4x, take away 10y equals 22. And the bottom one, 2 times negative 2x is negative 4x. 2 times 5y is 10y. And 2 times negative 11 is negative 22. Okay, 4x plus negative, oh, are we adding or subtracting? Since these are opposites, 4x and negative 4x, we're going to add. So 4x plus negative 4x is nothing. Negative 10y plus positive 10y is also nothing. So again, we end up with 0 on this side. 22 plus negative 22 is 0. So we get 0 equals 0. Is this true? Yeah, that's true. 0 is equal to true. 0 is equal to 0. So this is always true. And if you get something like that, 0 equals 0, 7 equals 7, negative 4 equals negative 4, what that means is that there is infinite solutions. Or, if we were to graph this thing, what does that mean about those lines? They are the same lines. Okay, that was a lot of stuff to be written here, a lot of different questions, a long video. I hope that makes sense. Rising, rising.